In the Blackjack AI exercise, what we're going to be doing is taking the Blackjack game we wrote before, and we're going to look at how changing the context of how we're going to be using it is going to pretty drastically change the way we design our code. So the best way I can show this is to go to our old code. And looking at this, you'll see that we have a lot of capital types. So that means they're exported types. We have a lot of types that start with a capital letter, which means that they're exported. And for a lot of these, we don't comment them or do anything about that because it's all used inside of this main package, which means that, this isn't a package that's going to be that people are going to import into their code and use. It's just, it's just a package that starts our application up and runs it. So this really isn't a big deal for this. But as we move on to designing this code for our Blackjack AI purposes, what we want to do is provide a package that allows people to give us an implementation of some sort of AI that will allow them to play the Blackjack game. And with that AI, they're going to play the game, but we don't want to export more than we have to. And a lot of the reasons why this comes up is you don't want to have an API that exports every single type and all these little details that are all implementation details. Because if you do, what will likely happen is that somebody will start to rely on those implementation details. And then if you ever want to change anything, it becomes really, really hard to do because you're going to break things for somebody. But on the other hand, if you really limit what you're exporting to just the bare, whatever they absolutely need to perform their tasks, then you can change some internal implementation details down the road without it really affecting your users because they didn't know about those details and they couldn't access them anyway. So if you look through here, you'll see how some of this is going to be changed. Things like the stand and hit functions are probably going to be changed in some way that they're not. There might be a public version of standing and hitting so that a user's AI can decide how am I going to, what's my next move. But things like end hand and some of these functions we have, we'll probably not end up exporting those because, the end user doesn't need to really see those. We'll also have to change some other stuff. I think coming down here and looking, things like game state are going to change because, we don't want to export the entire deck to the user so that they can interact with that. We don't want them to manipulate the deck because then an AI can cheat. So we're going to try to limit that a little bit. I'm looking here. So that about covers a rough idea of what I mean by that. I'm going to go back here. I'm going to try to explain what we're going to be building, like what the end goal is. This is an exercise that is hard to explain in the sense that we're basically taking code we have and writing it as a package that we're then going to use to build a Blackjack game. But that's very vague. So it's hard for you to really understand what I mean by that without jumping into the code, and I want you to be able to code it on your own if that's what you want to do. Now, a lot of you will just watch the videos and that's fine, but there are some that like to go code the things on their own first, so I'm trying to make that accessible. So in doing that, I do talk about here where one of the things you're going to want to think about is during the refactor, you're going to need an AI interface, and this is going to have some functions that you think your AI needs to play the game. In order to come up with what this should be, what I really suggest you do is think about what a human AI would be. So the existing game, if you were to take what the human player does and pull it out into its own struct or into some function calls, what information do you need to provide in order to actually let that player play the game? So coming back to our code, looking at this section here, and all the things that happen here. What sort of information is involved here and how does the player play their turn? So if you look at this, the two big things tend to be, we look at the player's hand and we look at the dealer's hand. So it looks like when we define our AI type, we're definitely going to need some sort of function that allows the player to play their hand. And we're going to need to tell them, here are the cards in your hand, here are the visible cards for the dealer's hand, what do you want to do? Some other things you might eventually need, we're probably going to want betting long term. You can start by just making every hand worth 1, but that kind of limits a lot of the strategies that you could potentially have. Specifically, whenever you're playing blackjack, most of the time people might vary their bets based on what information they have, especially if we try a counting cards AI or some sort of more in-depth strategy along those lines. So it's something where you might want to have an option for the AI to bet before their hand is dealt. And then another thing you might end up needing, which we don't have here, is that at the end of every hand, I think we do this in end hand. Yeah, we do. Excuse me. At the end of every hand, we print out what every player's hand was so that, we can look and see what the results were and go from there. So it might make sense at the end of every hand to print out the results, and you might need to sort of provide some functionality to the AI to determine if they won or lost a round, because the AI might be like, all right, every time you lose, double your bet. Every time you win, reduce your bet back down to 2 and start from there again. So, in real life, that's a strategy that wouldn't work too great for real players because they'd run out of money if they lost too many hands in a row. But, for your AI, you might be able to try it and just see what it's like. I also provide here a little bit of an idea of what I expect the main package to be. So the old Blackjack game, this one here that we have written, I expect this to mostly be moved into a Blackjack package. So you can do that inside of the existing spot where the code is. I'm going to be putting it inside of the Blackjack AI directory, so it's going to be nested like this. But you can do it however you want. And then inside of here, once we have that Blackjack package, it's going to be used inside of a main package that's just inside of this Blackjack AI directory. And it's going to be what starts the game. We're going to implement an AI there, and we're going to use it to play our game. So if you look here, this AI struct is going to be an implementation of the AI interface that's in the Blackjack package. So this will implement something like blackjack.ai. And once we have that, we're going to create the Blackjack game, and I'm just giving you an example here. I just have a struct called blackjack.options that has some sort of options that we might want to provide for our game. We create a new game, and then we call game.play and pass in our AI as an implementation of the AI for how we want to play the game. And then finally, once the game is over, we see what our winnings are and we just print them out. So this is just a rough idea of what it might look like. I don't even know if mine's going to look exactly like this, but I just wanted you to have a basic idea. And the last thing I'm going to mention is that, and I've sort of alluded to this, when you're refactoring your code and building this exercise, you probably want to add things like betting, splitting, and doubling down. Now, and also on top of that, you'll probably want to make it so that if a player gets blackjack, that their payout is different. I think 1.5 or 2x is pretty standard in different casinos. So you'll want to figure out some sort of payout for having blackjack for the player because that'll really affect the odds of the game. And you'll also probably want to add some logic in there to check with the dealer. If a dealer gets blackjack and a player doesn't have blackjack, the dealer wins automatically. So again, some other rules to sort of add to your game to sort of get it more realistic. And then finally, if you get stuck or if this isn't really thorough enough to sort of explain what the exercise is or what you're supposed to be doing, the first thing I would do is just watch some of the videos and just see if it sort of gets you on the right path. And if not, if you really want to code it on your own and there's just not enough here, or if you just don't understand something, feel free to reach out. My email's here. I'll happily answer questions and try to make it a little bit easier for you. So we're going to start by defining an interface that we need for a player or for an AI. What you call this is up to you. You might want to call it a player interface. You might want to call it an AI interface. I'm going to call it AI. I think that's fine. I think it sort of conveys what it's supposed to be. But realistically, it is really just a player of the blackjack game. So maybe that's a more appropriate name for you. That's up to you. But we're going to start with that because I want you to be able to see roughly what I mean when I say that we're going to define this interface that's going to be used to play the game. So that if you want to go try to code some of the rest of this on your own, you'll start to understand, where the interface came from, how I sort of decided what functions were on it, and, stuff like that you can build off of. So in my opinion, the best way, well, first I'm just going to go ahead and make the blackjack directory. Then inside of it, we're going to create ai.go. And this is going to be package blackjack. So in this, we want to define this AI interface type. But in my opinion, the best way to go about doing this is to actually have a real implementation. If you don't have one, there are cases where it's a little bit trickier, but if you can create an actual implementation, it's very nice because it will actually show you which functions you need and what data you require for those different functions. And it really makes sure that you don't miss things that you might have otherwise missed. So looking down through here, I'm going to sort of build a crude implementation of a human AI. And so basically it's going to implement this AI interface, but it's going to allow a player with a keyboard and a keyboard in the console to type in the responses, much like we were doing in the original game. And I'm doing this because I think whatever knowledge we need as a person to play the game is probably roughly equivalent to the knowledge that, our AI is going to need to play the game, because we're trying to keep those two pretty much in line with a realistic blackjack game. So I'm going to start by coming down here to main, and you'll see here that when it's a player's turn, they basically run this code. Everything inside of this for loop is basically what a player's turn ends up being. So what I'm going to do here is I'm going to say type human AI struct, and then we're going to start adding methods to this. So I think the first method we're going to add is play, and I don't know what it's going to take in. I don't know what it's going to return, but I know that it's going to do something like what this code was. So looking through the code now, I can start to see that the two things it definitely needs is, one, the current player's hand. We have to know what our hand is in order to be able to make a decision as to what we want to do next. So we could probably do something like hand, and this is just a slice of cards. I'm not going to do this hand type that we had in here. The big reason why I don't want to do this hand type is because it's really just a deck of cards, and I suppose we could make that work. I guess my concern here is that if we return a hand, then we sort of need to provide functionality for the user to decide, what is going on with that hand, what all can they do with it, and they almost have to jump into our code to realize that it's really just a slice of cards. I think it's probably easier just to provide them with a slice of cards and then provide a couple helper functions that sort of build on top of that. But I guess it's kind of up to you as to which you think is the best decision. I think for now I'm going to keep this simple and just keep these as deck, the deck.card type, so that if they actually want to look at the card and determine something else based on the card, like maybe they're counting the number of hearts that have been played for some reason with their strategy, it's very clear how to do that with this. Whereas if we have a hand type, it's not that they can't figure it out from here, it's just that it kind of hides that without really giving them without a major benefit. The only real benefits here is we have the score and the string functions, but you'll see as we go through this that we can actually just provide those functions to the user without this hand type. Okay, so anyway, we have our hand. What else do we need here? Well, we know looking down through here that the other thing we need is the dealer's hand, but we want a limited subset. We don't actually want the full dealer's hand like we had here. What we really want is just the visible cards. So that's what dealer string was doing. If you come back here and look, it was just looking at the first card, which is the only card you ever reveal from the dealer's hand until the game's actually over. So at this point, I think it makes more sense to say dealer and just return a single card. So that should be these two. And now we need a way to print these out. For now, I'm just going to go ahead and just put hand here. And then for this, I'm going to go ahead and just put dealer. And long term, we might want to replace this with something else, a function to print them out pretty or something. But for the time being, I think this makes sense. Okay, so the rest of this, it looks like we don't really take in any more information. We eventually read input from the user, but we don't need any more information passed into this play function in order to actually figure out what a player should do. From here, the next thing that comes up is what are we returning? So you see here that we're taking in the game state and we're applying either a hit or a stand function to it. And that's not really what we want to do here. We don't want our AI to be modifying our game state. Ideally, we'd take our game state here. Let me look for it. Ideally, we'd take our game state here, and all the internal details about the game state would be that. They'd be internal, they'd be hidden from our user or our AIs, so that our AIs can't really, they can't cheat. They can't try to manipulate things they're not supposed to manipulate. So what we kind of want to do here is we want to return a move of some sort. So we have some type called a move that we're going to return. And then we need to figure out what does that look like. Well, for now, I think the simplest way to start is to go figure out what does stand and hit look like. Well, it's a function that takes in the game state and returns a new game state. So we can just go ahead and define that here. And we can say it's a function that takes in a game state and it returns a game state. And I want this to be a type, not a func. Okay, so going on from there, what we can say here is this is going to return hit, and this is going to return stand. Otherwise, we say invalid option, and since it's possible to have an invalid option, I think it's a good idea to sort of just wrap this whole thing inside of a for loop, and then we're also going to need to declare this input variable. All right, so we don't have the hit or stand functions, but we know what they're going to look like roughly, so we can just go ahead and stub those out. This is going to take in a game state. It's going to return a game state. And then we can do the same thing for stand. And we know that both of these need implemented. That's fine. We also don't have a game state, so eventually we're going to want to go ahead and define that. So all of these are just kind of, this is all filler. And I say it needs to be implemented later. Honestly, what's really going to happen is we're going to be taking a lot of code from our main.go and bringing it into our Blackjack package and refactoring it as we do it. But this is roughly what the play function would look like for a player. They would print out their hand, they would ask them what they want to do, and then they would get an input and they'd return a move. So I think this makes sense as, roughly how a player would play the game. So now what we need to think about is, does a human AI need any more information? Well, again, we can come back to our main.go and we can start to see what are we doing here that might require information being presented to the user to be able to play the game or anything like that. Well, the most obvious one is pretty much anywhere where we print out stuff. So if we come here to end hand, at the very end of a hand, we get in both the player's hand and the dealer's hand. We print those both out, and then we also print out scores. But the scores are derived from the hand, so realistically, the only things we really need passed in are the hands. So thinking about this, I think what would make sense is to go ahead and say func. This will be part of the human AI. And I think it's a summary or a hand summary is roughly what we're looking at here. This sort of, or maybe you could call it result. It's really whatever you think makes the most sense. I think summary is fine. And this will provide you with the player's hand, which is a deck of cards, and then the dealer's hand. And this time it's going to be their full hand because, at this point, the dealer has actually finished doing whatever they're doing and we're seeing the end result of the hand. And then we can actually call this results. I think that's fine. And I don't think this needs to return anything. So we're looking back here. If you look at all this, this returns the game state that we created, but realistically, that's not us doing this. It's not something the player does. The game actually evaluates if you win or lose and does something based off of that. The reporting part is just, giving us information about what happened. So I think this is roughly what this would look like, and we could leave it blank for the time being, or we could do something like final hands and then do hand, and then down here we can just do dealer. And again, we can add things like score and that sort of stuff in later. Okay, so the third and final piece, well, actually, before I move on, let me go ahead and mention one thing. Down here at results, you'll notice that we're only printing out a single hand for the player. It's important to realize that this means that right now this interface does not support multiple hands for a player, which means that we don't support things like splitting. We will eventually change that. When one of the last videos, I plan on adding support for splitting, so the player can have multiple hands. And that's going to change some of this code. So if we had released this package, we'd have to do a major, a breaking change, a major version bump. And it's not the end of the world when you have to do that, but it is something you should try to avoid doing unless it's necessary. So in this case, it might make sense if you were planning on releasing a package like this to not release it until you actually had, the support for splitting added in, or just to go ahead and plan for it by maybe saying, all right, I think with multiple hands, really what this is going to be is a slice of slices of cards, which basically means that this part that's highlighted, the slice of deck of cards, let me go ahead and just copy it. This part here is what a hand is, and by adding the slice, the two square brackets in front of it, we're saying that we have a slice of hands, essentially. So we could do something like this, but for now, I'm actually not going to do it because I know I'm not releasing this, and it's just going to be easier to keep it, what we actually need for now. And then the last thing that we need here is a way to bet. I said before that if you wanted, you could just start with having your betting just always be 1, and just assume every hand is worth 1. But I know it's something I'm going to want from my AI. So what I'm going to do is I'm going to say human AI. It's going to bet. I don't think you need any inputs. Usually when you bet, you sit down at a table and you don't really have any extra information aside from like whatever you might have seen by watching other games on the table. And you're going to return an integer which represents whatever you want to bet. And I'm just going to stub this out with return 1 for the time being. So seeing this, as I said, you could change this to a slice of slices, or sorry, yeah, a 2D slice essentially of cards, and that will support having splitting the deck and that sort of thing. Actually, I take that back. I think I'm actually going to keep it like that for now because I want to give you the idea of what the final AI interface is going to be like. So if you want to go code this all on your own, you can. So I think it makes sense just to give you, this is what the final one is, and just be aware that the reason it's like this is because we're going to be supporting splitting, which means that every player will have multiple hands, or could potentially have multiple hands. They probably won't most of the time because splitting doesn't happen all the time. All right, so knowing this, we can actually copy all this and come up here to our AI, and we can start adding this in. So we have the results, we have the play, and then we have the bet. And this gives us a pretty good idea of what our interface for a player or an AI is going to be. As long as we have these 3 functions implemented, we should be able to build a bot that will play this game against our, just our dealer, and it'd be simulated and figure out how that bot's intelligence is working in determining what to bet and when to hit, when to stand, and different stuff like that. So I'm going to end this video here. I'm going to go ahead and just save the file so it's saved. In the next video, we're actually going to come through and we're going to start taking things like the game state and other parts from this, and we're going to move it into our Blackjack package and refactor it based on, what we think makes the most sense. But if you want to code this on your own, this is roughly what I think the AI interface is probably going to look like. If you want to try something different, you're more than welcome to, obviously. But I think this is, good enough to make it work. Just remember that if you want to add things like the score that was part of the hand, it might make sense to instead just define this as something like func score, and maybe this takes in some cards, and it returns an integer, which is a score. So this could be part of the Blackjack package, but rather than being a method on a type, it's just a function exposed that if you pass in some cards, it'll tell you what the Blackjack score of those cards is. And maybe you even want to change this to, instead of being just an integer, you could do something like soft, and it takes in some cards, and this will return a Boolean. So this might return whether or not a score is a soft score. So when we're looking here, we might want something like this that says, is this an ace counting as an 11, so that we could hit if we wanted to, especially if you're a dealer and you're trying to figure out that sort of thing, or if your AI depends on that. So these are the type of things that you can expose from your Blackjack package without actually having to, create a type and a method. Because I think in this case, it's completely fine to just expect people to be able to deal with cards and to, pass them in when they want to find out this information. Okay, so again, that's it for this. We're going to jump into actually refactoring things and moving all the code over in the next video. So now that we have this AI interface, I think our next step is going to be to go through here, the main.go that we had from before, and to try to pull out the pieces that we think make sense to put into our Blackjack package. So as part of this, I think I'm going to start by defining the game state stuff. So we have all this here, and it doesn't really make sense here, so I'm going to pull it out. I'm actually going to put it into another Go file. I don't want this. I want this. All right, so I'm going to create, I'm going to call this game.go. And this is again going to be in package Blackjack. And I'm going to grab this stuff here. I can grab the move as well. I think that's fine. All right, so I'm going to take this move and move it here. And then we're going to go ahead and fill out this game state, except I'm actually going to rename this to just be game. So I'm going to actually go through and change all of these to just game. And then I'm going to come back to AI, and I'm going to see, does anything here need to be changed? I don't think so. So I think we're good. All right, so then I'm going to come back to this main, and I'm going to figure out what information here can we pull out. Well, we've got the game state, so we can actually go grab all of this, paste it all in here, and then just rename this to game. And then from here, we want to go ahead and take a lot of the same information we had, but we want to go ahead and do it in a way that's not, I think we want to go ahead and set this up in a way that's not exported. We don't want any of these to be exported. So we'll put a little comment here that just says there are unexported fields, just in case somebody's looking at the docs. Then we're going to name this deck. We're going to have state. We're going to have the player, and we're going to have the dealer. I think that's good. These two hands are going to become deck.card because we're going to be taking a lot of the stuff we had before, the hand stuff, and we're going to be, and all the methods we had on it, and we're going to be exporting them in a little bit different way. So the next thing is the state. I'm just going to go ahead and just copy them as they were. If we need to change them later, we can, but I think for now it's fine just to copy them. And I'm going to go ahead and define these right here. Kind of like these near the top just because of what they are, because there's constants there. So I think I'm going to do this. All right, so we've got state player turn, state dealer turn, and state handover. I think we're probably going to need more states at some point, but this is going to be fine to start. And we might even decide at some point that the states are unnecessary. And I say that because before when we had the states, they were kind of just a way to sort of keep track of stuff. But once we go ahead and take this game and actually start to build it out, our players aren't really going to need to know much about, the internal state of this game. So realistically, I don't even think the state needs to be exported. I think this whole thing can be private. Same with these. We can just grab the capital state, make it a lowercase. And the reason I'm saying that I think that can be the case is that whenever a player is playing the game, their AI really only needs to know about things that are necessary to do this. So it's going to need to know about these different types of moves. It's going to need to know like what a move function is. But aside from that, it's not really going to need to know, the internals of the game. It's not going to be doing anything like this. It's going to just return a move that we're going to perform for them. So going beyond that, I do think it makes sense to change the names of these to move hit and move stand. The reason I want to do that is I want it to be very clear that these are moves, so that if somebody's, coding, they can type move and they'll start to see the autocomplete options. And eventually we're going to want to comment some of this, but I'm going to go ahead and let it be for the time being. Okay, so we have a lot of this. The next question is, what else do we need? So I think we're going to need this clone. At least the way we're currently writing our functions would require it. But another thing we could do is to, instead of returning a new game state with our move function, we could just change it to take in a pointer to a game and just edit it inline. So then for all of these, we can actually get rid of the return type. And I think in the last video I talked about how there are pros and cons to each approach. I think in this case, especially since all this data is really going to be hidden away from the user, it's fine to sort of just pass in a game and expect it to be modified inline. I think it makes a little bit more sense for what we're doing right now. So that's what I'm going to be going with. Okay, so what else do we need? We aren't going to need this clone function. We are not... I don't think we're going to need the current player function. I don't think it's going to make much sense whenever we, you'll see when we change our stuff, it won't quite make as much sense, or it might not. Maybe we'll come back and need to add it. We're probably going to want this draw function. It's a nice little helper. It's probably useful to have. So I'm going to come down here and add the draw function. And coming back through here, we're going to want a lot of the code in the main, but it's not going to be quite the same. So I'm going to copy this all, go back to our game, and what I'm going to do is I'm going to put func g game play, and it's going to take in an AI. So this is roughly how it's going to go. I'm going to paste in all of our code here, and you're going to see that we aren't going to be doing the shuffling stuff right now. Actually, for now, I think it probably makes sense to... We know that long-term we're going to want to be doing many, many hands. So we might want somebody who can play 100 hands in their simulator, or maybe 1,000 or 10,000. And if we have a deck of, say, 3 decks, so it's 3 decks of 52 cards, it's a little bit more than 156 cards roughly. Yeah, that's correct. 156 cards. So that's not really gonna cut it for 1,000 hands. So we're gonna need to shuffle in between at some point, but we don't really know how we want to handle that yet. So what I'm gonna do is I'm just gonna go ahead and assume that we're only playing 10 hands. I'm just gonna leave it at that for now. I think that's fine. But we already have the game, and we're going to, let me go ahead and do this real quick. We do want to shuffle the deck. So it's going to be something like shuffle, and we can do gs.deck. We could hard code this or use the shuffle function. I'm not sure which makes the most sense. I'm going to come look and see what's in shuffle. So copy this, come back here. Shuffle clones it, sets the deck, and that's it. So since all it's doing is setting the deck, I think it's fine to just go ahead and do g.deck equals deck.new, deck.deck3, deck.shuffle. Delete all this. And yeah, sorry if there's some background noise. Yeah, there's a little kiddo downstairs, so he's a little loud today. Okay, so once we have that, the next step, which you see here, is dealing. So let's figure out, does it make sense to pull deal out? Well, deal is a little bit more involved, so that one probably makes sense, but let's go ahead and paste it in here and see. So we make 2 hands, take 5 cards, and we go through and we deal each player 5 cards. So I think it's fine to go ahead and just keep this the same. So we'll call it a game. And we do not want to export this. We don't want end players to be saying deal is their move. That doesn't make any sense. We don't clone, and all these references to ret need to become just G. And I'll delete that part at the end. All right, so G.player, this is going to be lowercase G.dealer, and we're going to make a deck of cards. For both of these, we don't have the hand object anymore. And then looking back through here, we've got player, player, dealer, dealer. And every time we reference the capital deck, we need to lowercase that. So I think that's everything. And then the state here, we still have the state. So we're going to say state player turn. I think that makes sense for the time being. We might eventually need some more states again, but I think this is fine. So we're going to do this deal G. All right. Now when we look here at this part, the for game state, the state is currently the player's turn. We still want some of this to be the same. We want we want game.state to equal state player's turn. And in here, what we're going to do is we're going to say AI.play. And then we're going to pass in a hand and the dealer's card. So the hand is going to be gs.player, and then the dealer is going to be just the first card from the dealer's deck. So gs.dealer, 0. One thing I will mention here is that, I'm trying to figure out if there's, I don't want gs, I just want G. I called it game state before, so it was always on gs. And we're going to get a move out of this. So we're going to do something like this, and then we're going to do move with the game. So we can get rid of all of this, and this becomes really simplified. But one of the issues here that potentially you might want to worry about, it kind of depends on how protected you want to be. But it's possible that since you're passing this slice here, that somebody could swap some elements or do things like that, that would alter your slice. I think, with the way we're doing this, that's very possible. So I think what might make sense is to copy this at this point. So it might make sense to do hand colon equals make deck.card, the length of g.player, and then copy from hand is going to be the destination, and the source is going to be the player. And then from here, we'll pass in that hand. And this means that if the play function that we're calling happens to modify that hand, it won't really matter. It won't modify our game state. We won't have to worry too much about it. Okay, so now that we have all of that, I think the next thing we're going to want to do is come down here to the dealer turn section. And this is going to be roughly the same. It's going to be g.state equals state dealer turn. And then we're just going to basically say if the, we want the score. So we don't have a score function. So we're going to come back here. And I'm actually just going to take min score. Excuse me. We're going to want min score, and score. All of these are going to get copied. We're going to come back here to the game. Come to the bottom. And I'm actually going to say min score. This is going to be a function that instead of being a method on the hand, it's going to take in going to take in a variadic parameter, which is the deck of cards. And what it's going to do is it's going to range over the hand, and it's going to do the same thing it was doing before. So then up here, we're going to do the same thing. And I'm using the variadic parameter on both of these because for min score, I probably don't need to. But for score, I'm going to do it because I'm exporting this function. And I'm doing that so that anybody who's using this package can then use this to determine what a hand has in value. But there's times when the person might only want one card. For instance, if they only know the dealer's one card, they might call this to figure out what the score of that card is. So that way they don't really have to think about how do I implement the logic of is an ace worth 1 or 11 and that sort of thing. They'll get back 11 for an ace, they'll get back 10 for all the other cards that are face cards. We'll just give them a valid score and they don't really have to re-implement some of this logic. So as a result, having this as a variadic parameter is nice because they can pass in a slice if they want to, but they can also pass in a single card really easily. So here we're going to go ahead and say min score is min score of the hand. Another cool thing here is that since our hand is going to be a slice at this point, when we do this ... after it, it doesn't actually copy it, so it's not like it's really inefficient or anything like that. Okay, so we're going to look through here. I think the rest of this stays the same. So yeah, these two functions are not exported. This function is. What we could do is do a func soft hand, which is a deck.cards, and it's going to return a boolean. And this is going to tell you whether or not it's a soft score or a hard score. Sorry, I didn't mean to hit the mic. And what I mean by soft score or hard score is basically whether or not an ace is being counted as 11 points. So if an ace is being counted as 11 points, then this is going to return true. So what we're going to do is min score colon equals min score from the hand. Score colon equals score from the hand. If min score is not equal to score, return true. Otherwise, return false. And we could even take this last bit and we could return min score equal or is not equal to score. So if these two are not equal, then it's going to return true. Otherwise, it'll return false. Assuming I got that correct. Okay, so now we have a way to determine if it's a soft hand, if it's a soft score, if we can figure out what our score is. And I think that should be everything we really need to export there. So now we'll come up here and we're going to say if score of g.dealer is less than or equal to 16, then, or if the score, so what we're going to do here is we're going to go ahead and just store this value. So we're going to say g score, and I don't want g score, I want d score for dealer score. So here we can just say if d score is less than or equal to 16, or if d score is equal to 17, and if we have soft of the dealer. So in either of those cases we want to hit, so what we're going to do here is say hit G, and then otherwise we're going to stand with the game. And that's about it. And realistically, we could even pull this all out into an AI. So when you're looking at, up here at the AI type that we defined, we could actually define the way the dealer works as an AI. So we could say type dealer AI struct. And I don't think we're going to need anything inside of this. I'm going to say betting isn't really useful for the dealer because they don't really bet. So we'll just return 1. And this is actually one of the reasons why sometimes making the dealer an AI doesn't make as much sense, because if you look at it, the dealer doesn't really typically need to worry about betting. It does care about playing, and results, most dealers in blackjack casinos and stuff like that have a pretty static AI of, just do these things based on what your cards are. But we can do play. And this is going to be a little bit weird because this last bit's not really going to be, it's just going to be one of his cards from his hand. It doesn't make a lot of sense, but I think that's fine. So what we're going to do here is we're going to grab all of this, come back to the AI, and paste it in here. So we're going to say, we're going to score the hand. And if the score is less than or equal to 16, or the score is equal to 17 and the hand is soft, then we're going to return hit. And I think I named that move hit now. All right, so that's all the dealer's ever going to do, is either hit or stand. And that's pretty much all the AI for the dealer. And then the next thing we need is the results. So we're going to come down here and we're going to copy this human AI one. I'm going to bring it up here and I'm going to paste it. And I'm actually just going to change this to do nothing. So comment, just say it's a no op. Same here. So those two aren't really used, but play will be used. So now what we could do is at the start of our game, or somewhere up here, we could say dealer AI is going to be of the type AI. Whenever we construct this, which we don't actually do yet, but whenever we do it, we'll have to set that somehow. And then down here, what we can actually say is move : equals g.dealer AI dot play. And we can pass in a hand, which we want to be the dealer's hand. So again, we're going to do this copy thing like we did before. And we don't really need to worry about our dealer cheating, but on the off chance that players are, providing us with their own AI later on, if we make that an option, we might want to allow this. So we're going to say g.dealer. And then we're going to pass in the hand. And then for the card, this really doesn't matter. Any dealer AI shouldn't be using it. So, it's whatever you want to pass in, really. I'm just going to pass in the dealer's first card, just for consistency's sake. But, we aren't really going to be using it it shouldn't make sense because, it's just going to be the cards that are in the hand. So these two end up being very similar, you're seeing here. I'm just going to keep them separate though, because I do think it's a little bit easier long-term, just because the dealer's different enough from the player that with things like betting, if you end up just putting them all in a slice of players and consider the dealer just a regular player, the downside to that is when it comes to betting and stuff like that, it just gets a little bit wonky, especially with scoring and that sort of stuff. So having the dealer separate is sometimes very beneficial. All right, finally we have end hand. This is something in main that we probably are going to want, at least something similar. So I'm going to go ahead and copy it. We're not going to end up using all of it, but we might use some of it. So I'm going to go ahead and paste all of this down here. I'm eventually going to have to refactor a lot of this, but for now I just want to focus on coding it. All right, so a lot of this isn't going to work. I'm going to have to do score, g.player. Then here, I'm going to have to do score, g.dealer. All right, so we've got the two scores. And then the other thing that we might need to figure out is whether or not somebody, well, we don't need to worry about soft scores right now. So the printing out stuff we're not going to keep. This stuff doesn't belong in the end hand, in my opinion, because when we're running a simulation, we don't need to print a bunch of stuff out. If the user really cares about printing it out, they should add it as part of their AI in this here results function. But since we're not doing that, it doesn't make sense. And I'm not sure if I did this, if I just didn't update that. Those need to be move hit and move stand because we renamed the moves to be all prefixed with the word move. Coming back here, another thing to remember is that end hand, we don't want to export this. So I'm going to make it a lowercase e. And at the end of this, you're going to see that for all of these, we're just printing out whether or not we won or lost. So long term, we're going to want to go ahead and keep track of that. But for now, I think just printing it out is a good filler. What I'd probably do is something like a to do, and then say figure out winnings and add subtract. Then at the end, we're looking at player and dealer's hands. I think it's fine to say g.player equals nil, g.dealer equals nil. Just assign both of the hands to be nil at the end of this. But before we do that, I do think it is important that we need to call something like g.player AI. So we're going to need the AI. We don't have that here. And this is where you got two options, basically. One, you can pass it into this function. The second is we can make it part of the game. So, we could do something like player AI here and add it as part of the game. And then, when you call play, instead of just passing in an AI, it would be something that's there. It's kind of up to you as what makes the most sense. I think I'm just going to keep it as a parameter that we pass into the function call. And then later, if we want to change it, we can. So this will be I'll just call AI for the player AI. We're going to say AI.results, and we're going to pass in a 2D slice of deck.card, and the only entry in it is going to be the player's deck. And then for the dealer, what we're going to do is something very similar, except it's just going to be g.dealer. And looking at this, I'm actually thinking there's one thing that long-term we might want to do. I will mention I don't do anything special here with copying the player's cards or the dealer's cards, because at this point we're done with them. So if the results function tries to modify those slices, it just doesn't matter to me. On top of that, looking at this long-term, we might end up deciding that we want to pass more information in results. For instance, we could pass in somebody's winnings. Looking back at the AI, results here, we could pass in something like winnings, which is a slice of ints for, how much money you won with each hand. I think this would be useful, but I'm going to leave it out until we actually implement the betting stuff, just because I forgot to sort of cover it in the very first video, and I just completely forgot about it. So I think it's going to be fine as is. Okay, so I think that's a good chunk of this. I'm looking through here to figure out what I need to move around and what I need to sort of do. So score, soft, min, score, min. I'm going to actually copy all of these, and we're going to want them somewhere. I guess I can just put them at the bottom. I'm trying to figure out where I want to put this code in this file, but I don't think it makes too much of a difference here. All right, that is if an ace is being counted as 11 points. Looking through here to see if anything else. Move, stand, move, hit. We don't have either of those yet. So let's come up here and look and see what happens. You'll see here that all we do for stand is increment the state. And that's eventually going to change for our game, especially when we add the ability for a player to split. But I think for now we can just say GS, or yeah, I just want this to be G, not GS. But I'm going to say that. We also need to end hand with G. And we need to pass in the AI here. I'm going all over the place, so sorry about that. And then for move hit, what do we need to do for that? It looks like most of what we're doing here is just drawing a card, appending it to the player's hand, and then we do this last bit where we stand if the player's score is a bust. I'm going to do the bust stuff for now, but I'm going to warn you that it is going to be problematic here in the future. Specifically, when players can double down, what that really means is that you're going to hit with one card, you're going to double your bet, and that you're going to stand immediately after you hit. So when we code that, there's a chance that a player might double down, bust, and then we could double stand somehow. So if we reuse this hit part or move for part of doubling down, and then we were to do the other stuff, that would cause an issue. I'll show you more when we get close to then, but for now, I'm just going to tell you that it is possible. And the other thing we're going to look at here is the current player stuff. We have, where is it? Current player. I think this is a method that might be worth putting in here just because it's nice and simple to use. So I'll put this and current. I'm going to rename it to current hand because I think that's a little bit different. And it's going to give us a deck of cards. And again, we have to go change a lot of things here. And a lot of this is just refactoring to basically make things not exported that don't need to be. Okay, so we get current hand here. And I don't think this needs to be exported. We don't want the user to get access to these raw hands. So this is an unexported method. And then down here, we can actually come to this and say hand is going to be g.currentHand. And then the card is going to be declared there. And then we're going to say card and g.deck are equal to draw from g.deck. And then looking through the rest of this, we append a card to the hand, and then we say if the score of the hand is greater than 21, then we're going to call the move stand. And then we're going to return. So we don't actually need anything beyond that. And I think I need an asterisk here. Yes. Okay. So I think that's everything for hitting. We're going to test this here in a bit. By test, I mean we're just going to run it. I'm not actually going to write tests right this second. And we're going to see if this is working. But, you know, for now it's not terrible. I think we need to change that to range in hand. As you can see, I've got some bugs and stuff as I'm doing this. Moving a whole big thing over and refactoring tends to be a lot of, finding bugs as you miss things. Okay, so we need a new. I want some way to set up a new game, and this is where I need to find func main. And you'll see that we don't do a whole lot here aside from just game state. So we can probably get away with something like that here. We'll eventually take options for this new, but for now I'm just going to leave it as is because I want it to, I want it to just work as it is. So I'm going to return a game, and then from here I'm going to say deck. Well, we know that whenever we do the dealing part, where is that? Up here at the shuffle, this is essentially what this is. We know that we're going to assign that, so we don't need to do anything special. The state, I think we need to set to, I think it actually gets set someplace early on, but just in case, we'll say state player, or I think it's state player turn first. And then for the player and dealer will get assigned later. The dealer AI, on the other hand, will not, so we need to do something along these lines. Create an instance of this dealer AI type that we have over here in the AI package. And actually looking at this, dealer AI doesn't need to be a pointer. There's no real reason for it with anything we're doing here. So I'm going to, I guess we can do this. So I'm just going to go ahead and change this so it's no longer a pointer. And I think that's everything for the game. So we're going to create a main file now. So code main.go. Package main, func main. And this is going to be, again, very similar to what I had said. We're going to say var AI, blackjack.ai. And actually, we could just, I don't need that right now. Say game : equals blackjack.new. and this should import the packages we're seeing here. Then we're going to do game.play, and we need to pass in an AI. So we're going to pass in human AI. And I think this is going to be Blackjack dot human AI. And again, I think this is one of those ones that if I look at it, there's no real reason for these all to be pointers, so I'm just going to go ahead and get rid of them. I don't think it makes sense to keep them all. And right now we're doing human AI as a struct. And I think this is fine, but this is one of those instances where instead of returning the struct, if you really, since there's nothing exported, we aren't exporting any fields, and really the only thing that's coming out of this human AI is the interface methods, these bet, play, and results. If we wanted, we could very easily just change this to be func human AI. It's going to return an AI and return human AI. Something like this. So now we can come down through here and just make these all human AI unexported. And as a result, we're kind of hiding the implementation details from our user. And in this case, I think it makes sense because, we aren't giving them anything else in this human AI that really helps them. And this is an implementation detail that we might change down the road. Whereas a lot of times you'll hear people say, accept interfaces, return structs. This is, in my opinion, one of those situations where I don't know that that's necessarily a hard requirement or that it's as useful, just because the only thing we really do care about are these AI methods. All right, so with that, we can go back to this and we can say blackjack.human AI, and we don't need and in the front. And I don't think play returns an integer right now. So long term, we want this to return the winnings. So I'm going to go ahead and just return 0 at the end. If we wanted, we could keep track of, actually we could start doing it. Let's just do winnings right now as an integer. So we'll do balance int. When we create this, we'll say balance is 0. That should be the 0 value anyway, but we're going to go ahead and be explicit with it. And then every hand, when we come here, what we're going to do is we're going to say if you busted, g.balance minus minus. If the dealer busted, your balance is going to go up by 1. If you won, your balance is going to go up by 1. If you lost, it'll decrease. And on a draw, we aren't going to do anything. And we can simplify this a little bit later. We could keep track of a winnings variable and then at the end do the adding and subtracting. Then we could pass it to results. But I think for now, this is good. All right, so I just want to see, is this working? So we're going to say winnings. And we're going to print that. And I don't want to play too many hands while I'm testing this. So I'm going to actually go back to our game. And where we have this for loop, I'm going to limit to just 2 hands. All right, there's a good chance this will break, but we'll find out. So we have 10 of hearts, queen of hearts. That's a 20. We probably want to stand here. Dealer busted. And you're seeing here with the final hands printed out, we're seeing that we have a 10 of hearts, queen of hearts. Dealer has 8, 8, 10, so that's a 26 and a bust. All right, new hand. You can see here that this isn't printing out very pretty, so maybe we'd want to format that a little bit better. But we have a king of spades, 6 of clubs, and the dealer has an ace of spades. Maybe we want to stand here. Dealer busts again, so we got lucky. And at the end, we print out 0. So what's going on? Why is that balance not being updated? At least I think. Yeah, so we should have won in both of those cases. So now we just need to figure out, why are we not getting that? Well, I can tell you right now it's because of this. So let's go ahead and fix that. All right, try this again. 4 diamonds. Let's just stand, and we lose. And we're going to stand again, and the dealer busted, so we end up with 0. I want to see one more where that's not the case. All right, we lose, so I'm just going to keep hitting until we bust. All right, so you see here our total winnings are -2, what we expected them to be. So this appears to be mostly working. There might be some bugs somewhere. I haven't written tests for it. I haven't done anything beyond that. But you can see that we mostly have our code designed in a way that it's similar to how we had before with the game state. But now, as somebody who's using it, it's a very different interaction to use it. We've got the human AI function to get the AI. We've got the game.play to play the game, and we just create a new game this way. So what we're going to be doing in these next few videos, now that we have most of the framework here, is In the next video, I want to add in a bunch of options. So betting, doubling down, splitting, and blackjack payouts, I think, are the major ones that I want. And then once we have all those, the last video after that is going to be trying to actually come up with a reasonable AI that counts cards and gives us some sort of idea of how we end up doing with our counting card strategy. In this video, the goal is going to be to take the game that we wrote, I can save that, I think. This blackjack game we have set up, and we're going to expand it to add a couple features. Specifically, we want to add betting. We want some way for people to say how much they want to bet. Specifically, we want them to be able to do it every single hand. So before their hand is dealt, they want to be able to say, I want to bet $10 this round, or 1, or whatever it is. These aren't really going to have a numerical value, like a currency value. It's just going to be an integer. But you can sort of translate it into whatever currency or whatever you think makes the most sense in your head. But obviously we're not dealing with real money, so it doesn't matter. The next part here is blackjack payouts. If we're going to add the betting aspect, I think it makes sense to add blackjack payouts, which are usually either 1.5x or 2x or something like that. They pay out a little bit more. I'm probably going to use 1.5x, but I'm going to warn you that this one's a little bit weird in the sense that since we're using an integer for our betting, you'll probably want to default your bet to something like 10, is like the base, and then if you want to bet more, do it multiples of 10, or something like, or just consider 100 to be $1, so that you can actually do 1.5x, because I don't want to get into too much floats here, but we will need something like a float here with 1.5x, but 1.5 in an integer, it's going to have to get rounded, and that ends up being, not what we really want. So instead, I think it makes more sense to just try to keep your bets at like 10 or something like it's going to be a nice multiple of your blackjack payouts to give an even integer when they do pop up. Doubling down is just an option that a player has. Basically, it's doubling your bet, hitting, and then standing immediately afterwards. So you're saying you're only going to take one more card, and whatever it is, that's your final hand, and you're going to double your bet. Splitting is, I've got 2 7s here. Basically, it's anytime you have 2 cards that are the same value. It actually kind of varies depending on the blackjack table and the rules that are used there. But we're going to say if they're the 2 same face value or the same ranks on the card, we're going to allow the player to split it into 2 separate hands, and each hand will have a separate bet. So if you had one hand with 7-7 that you were betting $5 on, and you were to split, you would then have 2 hands that each have a single 7 in them. You're betting $5 on each hand, so you have to put more money down. And then you would play each hand against the dealer as if they were their own separate hands. There are a couple nuances here that I might not get perfect with blackjack. I'll try to keep it as in line with that as possible. Specifically, like after splitting, I think typically the dealer automatically deals you a second card as soon as they get to each hand, but they won't deal like 1 to each split hand right away. They'll let you play the one hand first and then let you play the other. It's easier on our end to either deal 1 card to each hand right away, or to just allow the user to say, I want to hit to get that second card initially. Both of those, I think, are just easier to sort of code. Similarly, when we're doing the doubling down, normally you wouldn't be able to hit and then double down. Our logic for doubling down is basically just going to be if you only have 2 cards in your hand, you can double down because that should be a default hand. But in reality, what our AI might do is we might split 7s, so we have 7 and then another 7. You might call for a hit because you only have 1 card, you'll get 11. And now since we have 2 cards, doubling down is an option, and you might double down. So it might look a little weird in practice, but functionally it's doing the same thing. Okay, so adding betting, I think that's the first thing we need. To do this, I think what makes sense is to do a state betting. Let's do something like this. And then I'm just going to go ahead and just push this all off. Oh, there's one more thing we're going to want. Reshuffling. So we're going to need something to reshuffle the deck. And I'm actually going to move that up here to the top. And it's going to be one of the first things we do. So we've got the state bet. I'm just going to leave that there for the time being, and we'll come back to it. I want to get the shuffling aspect done first. So coming down here to play, what I want to do is I want to say, I think this is all we really do for shuffling, is we just replace the deck with a brand new deck. So I don't think this needs its own function, but what we definitely want to do is something along the lines of pulling the number of decks from the game So up here for options, we'll have something like number of decks, which is an integer, or we'll just call it, and I don't know what you want to call it, numdex int. What else do we need as options go? I think I have some in the README. The number of hands we're going to play, the number of decks, and then you might want something else. I had something else I remembered, but I don't know what it is off the top of my head. So we're going to ignore it for now. So number of decks. So we'll just call this dex int, and then we're going to have hands int. And these are going to be exported options that you'll actually be able to set when you're, well, I don't know if we want them exported necessarily, but they're going to be options that are, the user can set here. So we could do something like type options struct, and here we can say dex int, hands int, blackjack payout. And this is probably going to be a float 64 is the easiest. So we've got those three, and then down here we'll go ahead and put these. So we'll do index int. We want to do hands int, and then we're down here with the balance. We're going to do blackjack payout, which is a float 64. So I think that's fine. I'm not exporting any of these because I just want them to be, I want somebody to be able to change them in the middle of the game somehow. So we're just going to keep them all like this, and I think that makes it clear that these aren't intended to be changed any other time. So then once we have the options, we're going to take options in here, and we're going to say that, so in here we're going to say that we need to use these options. So how do we do it? I think what I'm going to do is just assign this game to a variable, and then I'm going to say if ops.dex is equal to 0, then we're going to say we'll probably do something like ops.dex is equal to 3. And this is one of the reasons why you'll see functional options being used sometimes, is this is kind of annoying to sort of do, is to figure out if it's 0, what do we do? What are the defaults? And I'm not going to bother with constants right now for these. I think it's fine just to hard code these for what we're doing. So if ops.dex, not dex, hands is equal to 0, I want to do ops.hands equals 10. And then finally, actually maybe we want to make this 100. And then finally we'll see if ops.blackjack payout is equal to 0. Then we want to do equal to 1.5. And then we'll say g.ndex is equal to ops.dex. We can say g.nhands is equal to ops.hands. And we can do g.blackjack payout is equal to ops.blackjack payout. Finally, we'll return. I don't think I need the and there. Okay, so that's all of that. It's not the cleanest thing in the world. If we add more options, it's going to be kind of ugly, but I think for now we're going to have limited options, so this should be fine. And there's probably a better way to approach this, but again, we're just trying to get something working, so be it. Okay, so we've got the options there. Now we need to make sure we use them. So down here, we're going to go ahead and say for I is less than g.numhands. And we're going to actually say this is going to become g.numdex. And we need to add something for shuffling. When do we shuffle this deck? So we obviously don't want to let the deck get too low. If it gets low enough, then we could have potential issues with our code where we run out of cards in our deck to draw from. So for instance, if we have like 10 cards and 2 people are playing, maybe that's enough, but we're probably getting close to the end. But we also don't want to go too low as the casino. As the casino, you really wouldn't want to get too low because, if players are counting cards or keeping track of things at the end of the deck, well, they could almost know exactly which cards are left, and they can make much more educated bets off of that. So rather than allowing them to do that, what we might want to say is if, maybe if we have one deck left, we stop or we reshuffle. Well, the downside of that is that'll break the index. Or it would break it a little bit at least. So I think what I'm gonna probably do is say hand count is going to be 0. Then I'm going to say 4. I'm going to say max is going to be, actually I want to say min is going to be 52, which is how many cards are in a deck, times g.ndex. So this will get us the total number of cards we're going to have in our deck. And then we're going to divide it by 3. Now 3 is just an arbitrary number I picked. I'm going to say that when we've gone through 2/3 of our deck, we reshuffle. And your casino, your blackjack game can be whatever you think makes sense, but I think 3 is probably a reasonable number to go with. If we're only using one deck, that'll basically mean that, we shouldn't get low enough that we have an issue, but, we're not going to get, we're not just going to start the game and reshuffle after every single hand. All right, so we've got this min, and we're going to say for length of g.deck is greater than min. And then we're going to replace all of this inside of here. So here we're going to say the length of the deck is greater than min, and hand count is less than g.number of hands. We're going to say hand count plus plus at the very, very start of this to make sure we keep track of that. We're going to deal the cards, and we're going to go through all of this. I actually think this might make sense to change this a little bit. So we're going to say, let me go back to where we were. So I've got the minimum there. What I'm probably going to do is say, if the length of g.deck is less than min, sorry. If the length of our deck is less than min, then we're going to shuffle. So we're going to say g.deck equals this new deck. And then we're going to go ahead and deal. We don't really need this hand count, I don't think. And here we can actually just say g.deck equals nil. I think that'll work fine. So it'll just get shuffled right away. At this point, we're going to look into betting. And this is where it's going to really point out where I think we did something wrong, but that's fine. So the very first thing we would do here is ask the players to bet. So at this point, it's going to be the betting stage. And I added that state to the game, but I really don't think we need it, to be honest. Like a lot of this you're seeing is, I'm going to go ahead and just pull this out. A lot of this you're seeing is sort of just taken care of by our for loop, or by knowing the correct order of doing things. But right here, we'd want to bet with G. So we don't have that defined yet, so let's go ahead and say func bet with our game. What does betting look like? Well, we want to figure out what the player wants to bet for their hand. So we're going to look down here, up here at our game. And we want to put something like player bet. If I could put a capital letter, which is an integer. And I'm looking to see if there's anything else. Balance is something that's related to the player, so I think it makes sense to go up here. Blackjack payout is more of a configuration thing. I'm just organizing this a little bit for my own sanity. Okay, so these are all more configuration options. State is like the overall state of the game. Deck could go up here with state probably. And then we've got the player information, the player's cards, the player's bet, the player's balance. And then we've got the dealer and the dealer AI. So we know that we want to go ahead and set the player's bet inside of here. So what we're going to say is we're going to say we need an AI, apparently. So we're going to pass in the AI. So here what we're going to do is we're going to say AI.bet, and it's going to be a value. Then we're going to say g.playerbet is equal to bet. And I think that's all we have to do here. But one of the things I do want to mention that's kind of weird with this is that if we're counting cards or doing anything like that with our strategy, we don't know when the deck gets shuffled. But if we were in a real casino, at this point we would know if this shuffle had just happened because it's going to affect our strategy. As soon as the deck gets shuffled, our card count is no longer valid. So I think one thing we might want to do is something like shuffled is going to be false. And then here we're going to say something like shuffled equals true. And then here we'll pass in shuffled. And then afterwards we'll say shuffled equals false again. Although we don't really need this last bit because it always gets initialized to false. But we'll pass in shuffled here, which means that bet now takes in a shuffled Boolean. and we probably want to pass it into this. So that means we need to come back to our AI, and we're going to change this to shuffled, which is a Boolean, which lets us know if the deck was recently shuffled, in this last one. So we're not actually going to use it for our dealer AI, and again, we're not going to use it even for the player AI, because we don't do anything with it. But I am going to change this to bet 10 every hand, and the dealer doesn't really matter, so I'm going to leave it as 1. All right, so I think that's roughly what we need for the betting stage, aside from payouts. So if we come, I think it's down here at the bottom. I've got end hand somewhere. Right here. All right, so if I come to end hand, basically what we want to do here is we want to adjust our payouts based on, what was happening. So I'm going to do winnings is going to start off as 0. I'm going to say winnings is equal to, actually, I'm going to start off with the winnings being the player's bet. And then if the player busted, I'm going to multiply it by -1 to make it a negative winning. If the dealer busted, I'm not going to do anything. If the player score is better than the dealer score, again, it's still positive, so I don't have to do anything. If it's a loss here, we're going to say winnings times equals -1. You could also say winnings equals just negative winnings. If that's more clear to you, that's completely fine. Go ahead and paste it in here. And if the two are a tie, winnings become 0. Now, we're not covering blackjack yet, but I think that's okay. At the very end of here, we're going to say g.balance is going to be plus equals winnings. So basically, whatever we won, we're going to add to our balance, and if it's a negative number, we'll end up subtracting it. So, looking through this, I think that's mostly everything for the balance section, but let's go ahead and come back to the AI, and let's go ahead and make sure that's the case. So what we're going to do here is we're going to say, what would you like to bet? And I'm actually going to just sort of keep this fairly simple. Int bet, or wow, I'm just all over the place today. We're just going to return it here. All right, so now that we have the bet here with the human AI, let's go ahead and just test this. And not enough arguments. Oh, that makes sense. So now that we've added this options, we have to pass something in. And here we can peek the definition real quick to see we need decks, hands, and blackjack payout. So paste these in. And for decks, I'm going to go ahead and say 3, just like we were defaulting. Hands, I think I'm going to do 2, just because we're going to actually play this ourselves. We're not using an AI just yet. Blackjack payout will be 1.5, but again, we're not using it just yet. Pass that in, play the game, and see what happens. All right, what would I like to bet? We'll start with 150. Queen of diamonds, 5 of spades. Let's decide to hit, and we bust. All right, so we're playing a second hand. That was final hands. Okay, we're betting again. So let's say since we lost, we're going to double our bet to 300. 5 of diamonds, 9 of hearts. Maybe we'll stand here and just hope. Nope, we lost. All right, so our total payout is -450, which is what we expected. And again, if we were doing this, dealer busted this time, so we won with 150. Maybe we'll bet 50 this second time. And we lost that one, but since we won 150, lost 50, our final payout is 100 here. So you can see here that we have the betting working. We're not using the shuffled variable, so let's go ahead and make sure that's there. If shuffled, the deck was just shuffled. All right, so you see here we're getting the deck was just shuffled. If we play 100, stand, you'll see here the second time around that we're not getting that. So, we know that we know that the deck is not being shuffled whenever we go to place our bets. So our AI can sort of take that into consideration and decide how it wants to proceed. All right, so now that we've got this part working, What is next? We have betting, we want blackjack payouts. So this means that we need a way to determine if a hand is blackjack. Well, I think that's something that we might want to export to our, we might want to make available to our AI. It's not super important in the sense that they could probably look at the score and just figure out you only have 2 cards and know that it's a blackjack. But it's still something that might make sense just to make available in case it had more logic to that. All right, returns true if a hand is a blackjack. So if the length of hand is equal to 2 and the score of hand is equal to 21, that's a blackjack. So we're basically going to return if this is true, it's true. If it's not true, then it's not a blackjack. All right, so now that we have that, we're going to come back to our end hand code, and we're going to say that if the player score is, so we have a couple extra steps of logic here. Specifically, now that we have blackjacks, it's a little bit different in scoring. Specifically, if the dealer has blackjack, even if you haven't played your hand yet, if you don't have a blackjack yourself, the dealer will win. Now, a lot of casinos will have an insurance type stage where you could pay some sort of chips or something like that, some portion of your bet to get insurance in case the dealer might have blackjack, but we're not going to do that. We're also not going to end the game early, which technically makes the simulation not entirely accurate, but you could implement that if you wanted. I'm just not going to do it because it's just a little bit more annoying to do, I suppose. Although, maybe we will, who knows. Let me just get this part in first. So we have player blackjack and dealer blackjack. It's going to be blackjack, and we got g.player, and we've got blackjack of g.dealer. So now we know if either one has a blackjack, and we can actually come through here and determine winnings based off of this. So we're going to say case dealer, so player blackjack and dealer blackjack. So if both of them get a blackjack, it's a push. So neither one wins, it's just a tie. So here we're going to say winnings equals 0, and we're going to go from there. And I'm actually going to get rid of all these scores or all these you busted type things. And for these, I'm just going to go ahead and just put win in both of these just so it's clear that I'm intentionally not doing anything with it. All right, so case, if the dealer has a blackjack, we're going to say winnings equals negative winnings, because it doesn't matter if your scores are equal in this case. If the dealer has blackjack, you lose. And this is winnings equals 0. Not sure how it got deleted. All right, so then finally we've got the player blackjack, which is winnings times equals game.blackjack payout. So if the payout is 1.5, we're going to go ahead and do that. And you can see here times equal doesn't work because this is a float. So what we want to do is winning, we're going to do int winnings times, make this an int. Actually, we don't want to make that an int. And then we need to make this part a float 64. So when we're multiplying, these both have to be float 64s. And then we're going to cast them back or convert them back into an integer that we'll store in the winnings. All right, so I think that's all of that. I'm going to delete this print line again. I think that's everything we need to do for the winnings. Simulating this is kind of hard. So what I'm actually going to do is cheat a little bit. I'm going to, well, we could write a test for it. That's one way to verify it. Another way would be to just cheat a little bit. So is there an easy way to do that? We could go ahead and say, we're going to ignore whatever card's there. We're first going to append deck.ace. I don't think the rest of what's in this card matters. The ace is the important part. So we're going to say, actually, I take that back. I'm not going to modify this code specifically. Let me come back up here. In the deal, what I'm going to do is I'm just going to say g.player is equal to, and I'm just going to go ahead and replace this. So we have rank deck.ace. All right, so we've got an ace and a 10. So now if we go ahead and run this, what would like to bet? We'll say 100. We have an ace and 10, so that should be a blackjack. We'll stand, and then we're gonna go ahead and get it again. So we're gonna go ahead and wait. Oh, we're betting a second time. So we did 100 the first time. Let's do 10 the second time. And we're gonna stand again. And you'll see here that when we did 100, we got 150 as our payout. And when we did 10, we got 15 as our payout. So our total was 165. So that logic appears to be working there. Where we need to test it next is with the dealer. So what happens if we both have blackjack? So we'll test this real quick. And we'll bet 100 and we'll just stand. We'll bet 100, then we'll stand. And our final scores are 0 because it looks like it's giving us ties both times. And this is one of those where, since I'm doing this a couple times, I'm going to change the number of hands just to 1. The third test I want to do is if we have 21, but it's not with blackjack. So if we have a 6, a 5, and a 10. So say we bet 100, 6, 5, 10, that's 21. We're going to stand. Well, we still lose. And that was expected. Okay, so all three of these are working. Obviously I didn't write permanent tests, but I did at least make sure that they're working somewhat. So we have the blackjack payouts. The last thing that we can do with blackjack, if we want to do it, is basically at the very start of the game, we can do a blackjack check. And actually, we don't even need to do this much. We can say if blackjack g.dealer. Then at this point, we can actually just do end hand. And then we can continue through the rest of the for loop. So that'll skip all of this section here, all of this stuff. And I'm actually going to start putting a lot of this closer together because I don't really have a reason to keep it all as separated as it is. Okay, so that should cover blackjack. Just immediately doesn't let us play the hand, just goes ahead and ends it. We can test this again by coming up here in the deal and just, again, doing g.dealer is going to be a deck of cards or a slice of cards with rank deck.ace and 10. Let's go run it. Let's say we bet 100. You'll see here that we just automatically lose because the dealer has blackjack. So I think that's everything we need to focus on with the blackjack aspect. So doubling down. This one is going to be, where do we have? So this one's a little bit tricky because I think I mentioned this earlier. When you double down, you're basically saying hit and then stand right afterwards. Well, what we don't want to do is we don't want to have them hit, have them bust, have their score go over 21, and then have that cause them to, double stand. So if this is calling stand and it's calling move hit, because realistically what this is going to be is g.player bet times equals 2, and then we're going to say move hit, g, move stand, g. That's roughly what the logic of move double is. But we don't want that stand to happen twice. So at this point we need to figure out how do we handle that? And how do we move on from there? We also want to add some rules here. So if, let's say if g.player, if the length of this is not equal to 2, then we're going to say return, let's just say errors.new, can only double on a hand with 2 cards. So we're going to have this return an error, and now we're actually going to go up to all of these and start editing them so they return errors. And at the end of this, we'll return nil, and we're going to return nil here. All right, So we're going to return whatever move stand gives us here. So what I want to do here is I want to think about the standing part, and I'm going to actually change it to be an error instead. I think that might make more sense here. So what I'm going to do is I'm going to say var err bust equals errors.new and score exceeded 21. And then here I'm actually going to say if the score is over 21, return error bust. And then what we're going to do here is we're going to say if error colon equals this, error is not equal to nil. At this point, we would still need to move stand. So we might want to do, still do a move stand here. So I'm looking at it and I'm thinking it doesn't really change what we do here. So we don't really need to look at the error. The only error we know that can really come from move hit is the error bust. So I think it makes sense to just do move hit G and then do move stand G and return this. And then coming up here to this code, what we'd probably want to do is say on the player's turn, if the error is not equal to nil, we'll stand for the player. So it's a little bit more logic up there, but I think that's fine. We could, I don't know if there's a better way to necessarily handle this right now, so I think that's fine. We could also, we know we're going to have to handle other errors like this. Actually, I don't want to do this. I want to say switch error case error bust move stand with G. And we're going to say default panic with the error. So we're just going to go ahead and let our program just completely crash if they get an error like they try to make an invalid score. Or sorry, they try to make an invalid move. So one of these errors is going to stop our whole program. But an error like the error bust is not going to stop the whole program. Instead, it's just going to say, all right, well, then we need to stand for the player. They can't do this anymore. So that's why we're not returning the error here, is because we're already going to call stand, so there's no point in letting it stand for us. Okay, so I think that's everything for doubling down. It needs to be an option inside of our AI, though, so let's go ahead and add that. And we're going to say case D, return move double. And now we can go ahead and run this. All right, let's say we bet 100. Well, that doesn't make sense at all, but we can test it. And we get a panic. So apparently we're doing something wrong. So that means we need to come back to our code and figure out what's going on. So game 114. It looks like we're getting an error here. And I don't know which error we're getting. Oh, I know what the issue is. Case nil. No op. We need to make sure we account for the nil case. Or another thing you could do is if, you could do something like if error is equal to nil, or not equal to nil, then we run the switch. But I think it's fine just to do this. All right, let's try this again. All right, the deck was just shuffled. We're going to bet 100. We're getting always big scores here, but that's fine. We double down here. Our final score is king, queen, 2, so we busted. And we lost 200 instead of the regular 100. So if we do this again, I will bet 100, ace, ace. We can double here. We got ace, ace, 4, which means that our score was 16, I think. And then it looks like the dealer busted, so we got a final payout of 200. So it looks like this is working. The last piece is splitting, and this one's way more confusing. It's more confusing to me because basically when we look at the player, they can't just have a single deck of cards, but on top of that, their bet could be different for each, because we saw that, with doubling, you could double on, maybe when you have, when you split, you could end up doubling on each different hand you split on, so your bet is different for each individual hand. So what we end up having to do is something like hands is going to be a hand type. So we'll do something like player. And this sucks. This sucks because it ends up mixing up a lot of our code. So we have all this code that uses g.player, and it's basically going to make all of that stop working. We're going to have to come back through all of it and sort of fix it. So if you want to do this, it's up to you. I'm going to do it here, but I might speed up the video because I'm not sure how much value it adds just sort of watching me go do it all. But maybe not. We'll find out. So to start, I'm just going to go ahead and create a hand type. So I'm just going to create it. I'll just create it down here. I think that's fine. And the hand is going to be cards. It's going to be a deck of cards. And it's going to have a bet, which is an integer. So by default, a player is going to have a hand or a slice of hands. And they're going to have a balance and a player bet. So the bet is still going to be their initial bet that we're going to sort of work with. And when we create hands, it'll come from there. So dealing now, current hand is going to be tricky. We're also going to need to keep track of hand index. So I'm going to add that in here because we need to know which hand we're currently playing for the player. So whenever it's on the state where it's the player's turn, we know that we need to keep that into account or take that into account. And again, that's going to make our code a little bit weirder, mostly because standing is going to be different now. So just to write some notes down, to-dos. 1, stand needs updated. What else was I saying? A lot of these player errors are going to need updated. But we can just sort of go through there and try to figure out where the errors are now. So if we do go run, we should see some errors here. So we can start line 65. All right, so the current hand. What we really want to do here is return and g.player, g.handIndex. Dot cards. So again, this is a lot more you can see, but that's okay. And what we might want to do, this is going to return the current hand, which is actually good. The rest of our code, where we're doing g.player, it might make sense to do something like, well, nope, that won't work. Okay, so deal. G.player is going to be a hand, or we want to make a hand with a, or was I doing append here? Yeah, it was. So I'm going to do this. Player hand. It's going to be this. I'm going to go through all of this and just do it this way. That has to be colon equal up top. And at the bottom, I'm going to say g.player equals hand. Cards are going to be whatever is in the player hand, and then the bet is going to be g.player bet because that should already be set. And is that working? Is that? I'm not sure what it's complaining about here. Let me look. Oh. I need to put this inside of a bracket because it needs to be of the type hand. So this bracket is really saying that I'm doing a type hand like this, but you can shorthand it like this. Okay, so now that we're dealing, we're setting up, we're giving the player a single hand with the cards that we have here. And then we need to go down through all of this and figure out what we want. So player's turn. This ends up being a little bit different. We can still keep the state player's turn thing the same, I believe. What we're going to say is hand is going to be make deck.card, length of g.current hand. Oh, we just want len, not lang. Make sure everything else is... All right, so we got that part. Then we want to copy the current hand into the hand, and then we can do the rest of this, I think. This is all basically the same. Coming down through here, looking for more errors, and I'm gonna guess there's gonna be some. We get the current hand, that's roughly the same. This is the same. Standing is where we're different. So if g.handIndex is less than the length of g.player, so this is the number of hands. So basically, if we have more hands left, then we're going to actually take that back. We're going to g.handIndex plus plus, because we're going to move to the next player hand. So we're always going to do this. And then what we're going to say is if the hand index is equal to the length of g.hands, meaning that, or g.player, which is their hand, or all of their hands. If this is the case, if our index is at the length of the players, that means that we have no more hands to play. So at this point, what we're going to want to do is g.state plus plus. And we're also going to have to add a little bit of logic. So if is state dealer churn, so we can return nil here. So that's kind of a simple case. Otherwise, we're going to assume that the state is the state player churn, and that's the only state that should be called on. So if g.state state player churn, invalid state otherwise. Okay, and I'm actually going to pause the video here for a second because I'm running out of storage space, but I'll resume here in just 1 second. Okay, so I cleared up some storage space. What we're going to be doing now is updating this end hand function, but really it's not ending a hand. I mean, it is ending all of your hands, so maybe plural makes more sense, but I think what is a better name here is probably end round. And then I'm going to go up here where we call it, which is here, and change it to end round. I think round is a little bit clear as to what's going on, but I could be wrong. And then from here, we want to go ahead and say for each hand that a player has, and we're going to do something inside of here. But we still can calculate most of the dealer stuff up front, so we can say dscore. It's going to be score g.dealer. We can say dealer blackjack. It's going to be blackjack. G.dealer. Not with a capital letter though. And then we can iterate over all this. And for each hand, we're going to say, this isn't really a hand though. I mean, it is a hand object, but say cards are going to be hand.cards. And we'll say winnings are going to be g.bet. No, not g.bet. We want hand.bet. And I think that reminds me, we might have, we haven't even implemented split yet, so that's why it's not there. Okay, so there are the winnings. And now what we're going to do is we're going to go ahead and say the same switch statement we had is still roughly going to be the case, but we need to figure out p score, p blackjack. It's going to be score, cards, blackjack cards. And then we can take this switch statement, grab this whole thing, we can grab, I want all of this, I think. Except I don't want this first line. So we'll take all of this, indent it in a little bit. All right, so for each hand, we're gonna go ahead and we're gonna calculate whether or not it was a blackjack or whatever happened. We're gonna figure out what the winnings are. So we're saying winnings are gonna be the, I'm going to move this up here. And the winnings are going to be the hand.bet. Then at the end, we update the balance based on the winnings. So we can go ahead and delete a lot of this code down here. And then at the very end, we report results. And this is actually one of the issues with reporting the winnings, is we'd have to actually calculate the winnings for every single hand, or we'd have to call results multiple times. I'm not really sure what the best way to report that would be. So I'm actually going to leave results as is. That is, we're not going to add the winnings to it. It's not going to actually keep track of that. If the AI wants to calculate that, they can, because we're passing them the dealer's hand and we're passing them all the hands that are in the game, so they can sort of figure out if they won or lost any of them and go from there. And we've exported the blackjack function, a lot of that. But I think that just doing it this way should be fine. The only thing I need to do now is all hands is going to be make a 2D slice of deck.cards, and its length is going to be the length of g.player. And sorry about the background noise again. So basically, however many hands the player has is how big all hands is going to be. And then what we're going to say is, in each one of these, we're going to say all hands equals, actually, I don't think I want to actually do that. I'm not keeping track of the index, although I could. There's the we'll do HI for hand index. So what I want to do is all hands HI equals hand.cards. Something like that should be correct. And I can actually just do it this way now that I've got the cards there. All right, so all hands should get filled up. So then here we can pass in all hands and the dealer, and we can go from there. And if we wanted to test this, we could come back to our AI. And you'll see here where this is being done. We'll say forward to print line player. And then we'll do for each hand and the range of hand. This needs to be plural now. Let me come up here and see. I need to rename some of these. This should be hands. This should be hands. Basically, if I'm passing in a 2D slice, I think it makes more sense to call it hands because there's multiple hands there. And then here we're going to print out 2 spaces followed by the hand. Basically, we're going to indent them a little bit just to make it a little bit easier. And this will probably add a space as well, so we could probably just get away with 1, because this will add a second space with a comma. Okay. Let's see if this works. Undefined end hand. All right, this should be end round. All right, say we bet 100. We're going to go ahead and stand. And I'm realizing that we don't have any way to split, so we're going to have to sort of fake that. Well, first we need to add the split function, then we're going to have to fake it. So what does splitting entail? I'm trying to make sure, yeah, nothing broke there. So split is going to be a function that basically, as long as the 2 cards are identical, so if, so hand, it's going to be g.current hand. Cards are going to be hand.cards. And then we're going to say if the length of cards is not equal to 2, we're going to say return errors.new. You can only split with 2 of the same card. Or say you can only split with 2 cards in your hand. And then we'll say if cards 0.rank is not equal cards 1.rank. Return errors.new. Both cards must have the same rank to split. Otherwise, and I'm trying to figure out why, what are we getting here? I really need to do... No? What is it complaining about? Oh, current hand actually returns a hand. Or returns a card slice. I didn't realize that. So I want to change this to hand. And these 2 are going to be hand. This is the one that I need to add this to, which is kind of annoying, but that's okay. We'll add an asterisk here. So it's a pointer to it, so I need to use this when I want to get the value from it, and I wasn't paying attention to what the return value was there. Okay, so now that we've got this hand stuff, we've got most of the error cases. At this point, we should have a valid hand to split with. So what we're going to say is g.player, because the player is the only person that splits. The dealer never splits, so we don't really need to worry about that part of it. I guess we could add an if the state is not the current player, then we error, but I'm just going to let it be for the time being. So we'll do g.player equals append g.player, and the cards are going to be whatever is in this hand at index 1, and then the this actually needs to be a slice though. And then the bet is going to be whatever the current bet is. So this hand is going to return the wrong thing. Let me go down here and look. Where is current hand? So this is returning a slice of cards, which isn't, technically it's not what we necessarily want it to do, but. So I need to get the current hand. So what I'm going to do is just go ahead and access it directly like this. So I'm going to go back. And this is a little bit uglier than I prefer, but I just want to get it working. And then, later if I wanted to come back and refactor it, I could easily do that. So I want to get the current player's hand, and I want to get the bet from it. And the reason I'm not using the player bet is on the off chance somehow this hand has a different bet, we want to go ahead and use that bet. But it shouldn't. That shouldn't actually be possible. But just in case, I'm going to go ahead and do this. All right. So hand is not a type. I thought it was. Did I miss something? Yeah, we have a hand type. So what is it complaining about? Oh, it's because I do this. So I'm going to say cards up here. So I got to go through and refactor a bunch of stuff. And I want to make that cards. I need to do parenthesis here so I can index it. All right, so we create a new slice of cards that just has the card at index 1, and we set that into the, we add that to the player's hands. We set the bet based off of this. So the last thing we need to do is we need to say that cards needs to become a new slice. We don't want it to be the same slice it was. So we're going to say that the value that cards points to is going to now be just the first item in the slice, and I need to put the parenthesis there first. So I can do something like this, and then I can return nil. And that should do everything we need to split the cards. So to test this, I'm actually going to go up here, and where we deal our cards, I'm going to go ahead and just give myself, or make sure the cards are something that are splittable, so we can go from there. So I'm going to say player hand equals append player hand. Actually, I don't want to do that. I want to do, and then here we're going to do rank deck dot 10. We'll do 7, and we'll just do 2 of those. And then finally, we got to go to the AIs. We need to go to the human AI, and we need to add a case for splitting. We'll put a P for split, just because we need a different character. And you will notice that if the human player is playing this version of the game and they type in an invalid move, we will probably actually error. I'm going to go ahead and show you that. Bet 100. Let's say, well, we can split here, so there isn't really an invalid move. So we'll look at that here in a bit. So anyway, splitting didn't appear to work. So we got to figure out why that's the case. So let's say if we stand here. So it looks like what's happening is we're getting the first card. We're getting it cloned into a new slice. But what we're not getting is, this card isn't getting removed from the first hand. So we need to go back to the definition of move split, and we need to figure out why that's the case. So looking here, we need to figure out what is going on that this isn't actually working. Well, let me see here. My guess would be that it's something to do with this current hand function. So the easiest way to figure that out is to do something like this. And then to go ahead and try this again. And that gives us a 7 of spades here, which seems to be correct. So if I stand there and then if I like hit on the second one, which I didn't mean to do HG, but that's fine. All right. So you can see here that it played the game correctly. We lost both hands, that's fine. But something was going on there. If I had to guess, I don't want an online link. If I had to guess what was going on here, it's something to do with the fact that I'm probably not, this hand object might have a different set of cards that it's referencing, a different slice. So I'm not necessarily getting the right one. I'd have to go toy around with it to figure out for sure. So I'm not going to do that. Instead, I'm just going to kind of let it be as is. I think that's fine. We got it working clearly, so should be all right. Yeah, so I think that's it for this. I don't want to dive too much farther into any of this. One, because it's not that this isn't interesting, but I think the AI side of it's a little bit more fun to code. So I'm sort of excited to get there, and I know that these videos have already gone pretty long. So I'm going to go ahead and end this, try to splice up the videos and stuff and get them started to be released, and then I'm going to jump into building out the AI. The last part of this exercise is what I consider the most enjoyable part. I'm going to warn you now that I'm going to probably implement a pretty crappy, a pretty bad strategy for blackjack. But if you want to, if you Google blackjack strategy, and you'll see that there's a ton of strategies out there. So we can look at some of these, and a lot of these are even specific to how many decks you have, all sorts of other things like that. There's a ton of things you can learn, but I'm going to just go ahead and implement a fairly simple strategy of, maybe hit on a couple things, stand on a couple cases, maybe we'll only split on one specific case. And I'm just doing this because I want you to see what it's like over a large number of games so that you can sort of go from there. I also want to mention that card counting, blackjack, if you Google this, there are some different websites that'll sort of discuss what it's like. We're going to go ahead and implement it in our code. You'll see it. But the basic strategy we're using is that for low cards, we add 1 to our count. Middle cards, we do nothing. High cards, we subtract 1. And then depending on how many decks are left in the game, so basically if there are, say you're playing with 4 decks and there are 2 decks left, you keep track of how many cards have been played, then you use this to sort of influence whether or not you want to bet higher or lower. So basically as this count is higher, they call it the true count here, where basically the true count is the count that you keep track of with these +1s and these -1s divided by the total number of decks remaining. They show it here. If that's higher, you want to bet more. And if that's lower, you want to bet the minimal possible. And then the last thing is going to be, there are packages like this Impl one. These are really cool let me just go ahead and show you. We want to go ahead and implement, let's say we have a type. Let's just say basic AI. And with this type, we want to implement the blackjack.ai interface. So we want to go ahead and just stub out all those methods so that we can start coding them. Well, one of the things you can do with this is go get this library. Then you can do impl, and then in a single, or in quotes, you can sort of just put what you want the signature to be inside of the method, where you declare the actual type. So I'm going to call it AI, basic AI. And then the next part is the interface you want to implement. So blackjack.ai. And you'll see here that it spits out all of the stuff I need to stub out an implementation. So I can come back here now, paste this in, and while they'll all panic if I call them, you can see here that I really have a basic implementation to go with. So from here, we're going to start implementing that. But before I do it, there are a couple bugs in our code that I realized as I was sort of testing this stuff out and getting ready for this video. So I just want to sort of go through them all so you can see what they're like. And I'm sorry that if you tried to use the code and had issues. But in game, in the game.go file, the first thing we're going to want is something here. So if the bet is less than, we're going to say less than 100. This isn't technically a bug, but I want to simplify our code to say that you have to bet at least 100. Otherwise, we're going to panic. Bet must be at least 100. And this is mostly here just in case, while we're testing things out and getting used to it all. if we ever do an invalid bet, then we want to go ahead and just make sure we know about it. Long term, what I would actually probably do is give your AI the option to quit at any point in time if it wants by betting 0 and like letting them stand up from the table. So we don't have that option now, obviously, but long term, that might be something you want to do. So the next thing, we have deal. So we have all the stuff with the hand index. Let me come up here. So this part here. So every time that we do move stand, you'll see that we increment the hand index, but we never actually reset that back to 0. So what we want to do to fix that is we want to go back to the deal function, and we want to go ahead and add something here. So we're going to say g.handIndex is going to be 0. So whenever we're dealing a new set of cards, we're going to reset some of this. So we're resetting the player's hand, and we'll go ahead and say that their index is now 0. The other thing we're going to want to get rid of is this right here, hard-coded double sevens. We don't need that anymore since we're not doing it. And then I think there's one other thing in move double. Yeah, so whenever we change g.player, this now represents the player's hands, but that's still a slice, so it still has a length. So this didn't ever give us a compilation error, but it isn't what we wanted logically. What we really want here is if the g.current hand, so if the current hand's length is not equal to 2, then somebody cannot double down. It's not possible then. So that's only allowed in this situation. So I think that's all of the errors. Let's go ahead back to our code and in our main.go, and let's implement this stuff. So what we're going to do here is we're going to say bet we're just going to return 100 every time. We'll eventually add the card counting like I said, but for now I'm going to leave it as 100. So playing, what we're going to do here is a basic strategy of, I think we're going to say if, we'll say score is equal to blackjack.score, hand. Then we'll say if score is equal to 10, then, let's see, when do we want to double? I really don't want to go through all of this. So if the player has a hard 10, well, I don't really want to look at hard and soft at this point either. Okay, so what I'm going to go ahead and just say is if the score is equal to 10 and blackjack.soft of the hand, we'll say not blackjack.soft. Then let's go back here and look again. 10 or 11 and we're going to hit. So or score is equal to 11. Put these two in parentheses. Then we're going to return, and this needs to be inside of an if the length of hand is equal to 2. So this is where we're considering whether or not we want to double. So if the score is equal to 10 or 11 and it's not a soft hand, return blackjack.move double. We don't want to actually call the function, we just want to return the function. And before that, we might want to do something with splitting. So what we might want to say is if score of just the, so if hand 0 is equal to hand 1. So at this point, we can split if we want. We're only going to split on certain situations. So let's go ahead here, and you'll look that if you look at the splits, there's very unique situations where you do it. It looks like they always want to do it on ace. You almost always want to do it on 8. The rest of them, it kind of varies. 9s are pretty consistently, you probably want to do them pretty often, but it depends. So let's just say 8, 9, and ace. So if hand 0, so here we might want to do something like single score or card score. And then we'll do blackjack.score with the first card. So we know both the cards are the same. So what I'm doing is I'm getting the score for a single card. Then I'm going to say if the card score is greater than or equal to 8 and the card score is not equal to 10. So basically we're saying if it's 8, 9, or ace, then we're going to go ahead and we're going to return blackjack.move split. Otherwise we don't want to. And then finally, once we get out of this, if the length is equal to 2, we decide just do we want to hit or do we want to stay? Well, It really depends on which strategy you want to go here. You can see, again, there are big tables that have all sorts of differences. What I'm basically just going to say is if the dealer score is, so I need to actually calculate that. So if the dealer score is going to be blackjack.score, the dealer's card. So the dealer only has one card, so we're just going to have to kind of go based on what we're seeing from them. So I'm going to say if the dealer score is equal to 6, we'll say if it's greater than or equal to 5 and the dealer score is less than or equal to 6. So basically if it's 5 or 6, but I'm going to do it this way so we can change the range later if we wanted. Return blackjack.move stay or stand. Otherwise, if our score is less than, we'll say 13, return blackjack.move hit. And finally, return blackjack.move stand. So again, I don't, let me make sure I'm not, I need to put ... here. All right. So this is definitely not an ideal strategy. You can see here that it's not doing anything near close to like the complexity of what's here, but it is just doing something that we can sort of test and see how it works. Lastly, results. This is going to be a no-op for now. We're not counting cards or anything, so we're just going to leave that as a no-op. Coming back down through the rest of this, we're going to change this a bit. I'm actually going to change this to, let's go to 50,000. Number of decks is going to be 4, and the blackjack payout's 1.5. So we're actually going to run a lot of simulations to sort of see how this strategy does. And I'm going to go run main.go. And we have an issue because I'm still using the human AI. So what I want to do here is basic AI. And it needs to be a pointer because these are all pointer methods. So I'm going to put the and in front of it. And we'll run it. All right, you'll see here that we lost 330,000, 370,000, 349,000. We're losing every single time. But what's kind of interesting is that our strategy seems to be falling in, not in an exact area, but it's got a roughly, a rough ballpark where it tends to sort of lie after playing 50,000 hands. And that's one of the cool things with running the simulations is that while it's not perfect like statistics can be, it can give you a ballpark idea of how something does over a very large, data set. Specifically, if we were to take this data set and, make it even higher, like if we went to something like this, 999,000 hands, and this is going to take a while to run, but you'll see that, we should start to get much more consistent numbers, or slightly more consistent numbers, I guess, in the sense that these are all, we're starting to fall in this pretty similar area. Okay, so we've got this running. The next thing we want to do is I want to go ahead, let me go ahead and marker this. So the next thing I want to do is I want to add some basic counting. So we're going to go to this Blackjack AI and we're going to add some count, which is the integer. We're going to add a scene, which is an integer for the number of cards seen. And then we're going to keep a dex, which is the number of decks total. So down here, we're going to actually say scene is going to be 0, count is going to be 0, so dex is the only thing we have to set, which is 4. Or dex, plural. So from there, the other thing we need to do is when we shuffle, if shuffled is true, we need to say count is going to be 0, ai.count equals 0, and ai.scene equals 0. So basically, anytime we see either of these, we need to make sure that basically that we don't that we reset them so that we don't try to keep our count up, even though the deck was just reshuffled, so our count is no longer useful. So beyond that, we need to go ahead and we need to say for each card in the dealer's cards, we need to basically do the counting. So we're going to say score is going to be blackjack.score dealer. And then we're going to say if score is greater than or equal to 10. So this is where we say ai.count minus minus. So this is where if we have a 10 or an ace, we want to go ahead and decrement our counter. And let me make sure that we're not getting any sort of issue. Oh, I need to put ... Oh, we want card here. That's why that's an issue. Okay, so if that single card has a score of 10 or 11, we want to decrement. And since we're going to do two different cases, I'm going to do switch. Scores greater than, let me go ahead, case, scores greater than or equal to 10, AI.count minus minus, case score is less than or equal to 6, AI.count plus plus. So basically if we get a card less than or equal to 6, so 2, 3, 4, 5, 6, we're going to go ahead and increment. If we get one, any higher, we're going to decrement. And we know aces should always show up here in this upper section because we're not using the rank, we're actually using the score from Blackjack. And if you only have one card in your hand and it's an ace, we should get a score of 11 as our maximum score. And then the other thing we want to do is AI.scene increments. So we need to say that we've seen more cards, and we're going to see why that matters here in a bit. So I'm going to actually take all of this, copy it, and I'll move it into a method. So basic AI, and this is going to be, what do I call this stuff? I'm actually going to change this to score. And then here I'm going to call this count. So basically what this is going to do is, all right, so this is doing exactly what we were doing before, except we're going to go ahead and just add it into a method so that it's a little bit easier to use with everything getting updated, but also so that we can do something like this for each hand in the range of hands, and then for each card in those, in each hand, and I need to add the word range here. We're going to do AI.count with that card as well. So now we should be counting every single card that we see at the end of every single game. And with that, we can sort of update our total counts so that we know how much to bet the next round. So that brings us to the betting section. Up here, the easiest way to sort of do this is if, we'll say, we need to calculate the true score. So we'll say true score is going to be, it's the AI.score divided by, if we come back to this, the running count divided by the decks remaining. So AI.score is the running count. The decks remaining is going to be decks times 52 minus AI.scene. So this is how many cards we have left. And if we divide that by 52, it should tell us how many decks are left. So put this all in parentheses just to make sure, it's sort of organized as to what we want it to be. And this needs to be AI.decks. What am I doing wrong? Oh, true score is declared and not used. Okay, so this will give us the true score that we're talking about. And then I'm going to actually just add something for now that says if true score is greater than, let's say 6. Actually, let's say 10. We're just going to print out AI. And I just want to run this, and I'm going to cancel it. You'll see that we're getting different situations where the true score is definitely higher than what than 6. We don't really know what the outcome is because we're not affecting our bet based off of that, but we want to kind of have that here. So I'm going to actually just let's just start with 2 tiers. If true score is greater than switch, case true score is greater than, let's say 14. Return, let's do a much higher bet. Let's do 10,000. We'll say if true score is greater than 8, then we want to return a higher bet, but not much higher. And then default is going to return 100. All right, so this is where our counting really comes into play. We're taking what we're getting from this true score and altering our bet based off of it. And this is the thing where casinos will actually watch for people doing this. And that's when they'll start to kick you out of the casino and not let you come back anymore. So this is why card counting really doesn't work very well in practice, is you have to somehow up and increase and decrease your bets without being obvious about it, which is almost impossible. Okay, so we're going to run this. You're going to see that we're still losing a lot. While I think our card counting strategy, let me go ahead and back here and change this. Actually, one of these to be greater than or equal to, but I don't know if they're necessarily going to. Yeah, it's not going to change this very much. Okay, so what's more than likely happening here, you can see here that we're ranging from, we've got a much bigger range because we're increasing our bets every once in a while. The other thing is, if I take all this, comment it out, and just return 100, I want to see what we get back. Okay, so we're basically in the same, we're in the same category of number, as far as like how much we're getting for us or against us, but we fluctuate a lot more with this card counting. Well, what's more than likely happening is card counting doesn't work very effectively when your strategy is not good. So our basic strategy down here is not very good. So if you wanted to see this work perfectly, what I would really suggest doing is coming back to something like this and trying to actually implement this nice set of rules that you're supposed to have and sort of going from there. So you can look at all this and sort of figure out, all right, what does it make sense? And that doesn't mean that you're necessarily going to have a great advantage at winning, but it should give you an idea of, how counting cards can start to affect things and give you a better chance at winning. And I'm assuming that I coded this all correctly, but there's always a chance that I just have some of this brutally wrong. And that could also be a factor in this. So I'm actually going to try something different here. I'm going to increase these bets by a ton, depending on what's going on, and just sort of see how it affects us here. And you'll see that since we have that increased bet, you can definitely get very negative numbers, but we can also get much better numbers than we're normally seeing on average with our strategy, which is a pretty bad strategy from what we've seen. So, clearly we can get some really, really bad. And here you can see that we can even get positive, which is a huge, huge swing. So part of that is just the fact that our bets are going up and down by a lot more. But part of it's also the fact that, we are betting larger numbers typically when we should have a better chance at winning, even with our crude strategy. So, it's going to have a bigger difference in how we end up. So that's it for this. At some point, I very well might come back through and code up a smarter AI here that has an actual legit strategy. But for the time being, I just want to get these videos out. And I want you to be able to toy around with this part yourself, because I do think this is sort of fun to mess with to see how different strategies work. So I'm going to end the video here, and hopefully you enjoyed it.